All right, what we're going to be covering today is review all from the very first unit of work that you did, which seems like many, many months ago, which it was. Starting off, I'm going to pull this up on my computer. And we started off kind of reviewing work from IM1. We covered a couple things. One of the things that we covered was area. We covered areas of triangles, of parallelograms, and trapezoids. I'm just going to assign some numbers to these. All right. Now, let's say I'm asking to find the area of these shapes. Remember, area of a triangle is 1/2 base times your height. So 5 times 3 is 15. Half of that is 7.5. And remember, when there was no unit of measure, we would always say units squared. For a parallelogram, if this side's parallel to this, and if these two sides are parallel, you would take base times your height. 6 times 8 is 48, and we would say it is units squared. This 10 is here just to confuse you. You don't really need it if you're trying to find the area. This is the slant height. Remember, for a trapezoid, you take the base 1 and base 2, add it together, and then cut it in half. 10 plus 12 is 22. Half of 22 is 11. And then you times it by your height, giving you 44 units squared. Remember, the formula for a trapezoid is B1 plus B2 over 2 times your h. That's the formula for the area of a trapezoid. Okay, so the next thing we talked about was graphing. Simple graphing. We're going to get into graphing a lot more in depth next semester. But the very beginning of the year, we just reviewed basic y equals mx plus b graphs. Y equals mx plus b, where this is your slope, and this is your y-intercept. Let's take, for example, y equals negative 2/3 x plus 1. You all should know how to graph this, but if you don't remember, this is your y-intercept, which is 1. You just go up 1, then you go down, because this is a negative, 1, 2, and then over to the right, 3. There was a couple funky graphs. One of the funky graphs was, let's say we had y equals 1. Y equals 1 would look like this. We would go up 1 and draw your horizontal line. How about an x equals 1 graph? If we had an x equals 1, we would go over to the right 1 on your x, and it's a vertical. Remember, these graphs have a slope that is undefined. Y lines, if this was a y lines look like this, and remember, these have a slope of 0. We covered lines, and then we also covered writing equations of lines. And then I reintroduced to you the equation for your slope given 2 coordinates, which is y2 minus y1 over x2 minus x1. Now I said, let's take, for example, we have 2 coordinates, 1, 4, and 0, 3. And the question is, find the slope of these 2 coordinates. What you're going to do is you're going to plug in y2 minus y1, 3 minus 4, over x2 minus x1, 0 minus 1. So this is going to equal -1 over -1, which is a positive 1. And then the little more difficult one was writing this as an equation of a line. So if you have two coordinates, once you find your slope, this part is done. Now you got to find your y-intercept. And you're going to take one of these coordinates. Let's use 1 and 4. I'm going to plug a 1 into my x, 4 into my y to solve for my b. So I would have, substitute that 4. 4 equals 1 times, plug in this 1 into this x, plus b. 4 equals 1 times 1 plus b. So my b equals 3. That's my y-intercept, and I'm going to plug this in. And this is my equation of a line given those two coordinates. Okay, and then we kind of steered away from graphing, basic algebra, and we started talking about bisecting and line segments, complementary, and whatnot. So remember, complementary versus supplementary. Complementary are two angles that add together to give you 90 degrees. So this angle and this angle add together to give you this 90-degree angle. Supplementary are two angles that add together to give you a straight line. That's what supplementary is. Supplementary would be this angle plus this angle equals 180 degrees. Complementary are two angles that equal 90 degrees. Supplementary are two angles that equal 180 degrees. For example, let's say this was 20 degrees. This would be, if this is x, you could figure out that x equals 70, and so on. Okay, we reviewed as well parallel lines and their properties. So let's take a set of parallel lines and a transversal line that cuts them. These two are parallel. Let's say this is 100 and, let's say, this is keep it easy. Let's say this is 120 degrees. If this is 120, these two angles are called corresponding angles, and they're the same. These are vertical angles, and these are vertical angles. Or these are called alternate interior angles, and they're the same. You see how everything works out? Okay, this is 120. This would have to be 60 to give me 180 degrees. Now look, 60 degrees, these are called alternate exterior angles. Everything works out no matter how you do it. Or you could do this. These are vertical angles, 60 and 60. And then this angle and this angle are corresponding angles, and they're the same. Or this angle and this angle are alternate interior angles, and they're the same, which gives you vertical angles. No matter how you do it, everything works out to a nice and clean puzzle. The last thing that we kind of talked about was bisectors. So let's say we have an angle like this. And let's say we're told that this angle is 9x plus 3, and this angle is 8x plus, let's say, 94. Now, we are told that this line bisects this angle. So this angle and this angle are exactly the same. Could you set an equation up to solve for the x? Sure. You could say that this angle, 9x plus 3, has to equal this exact same angle, 8x plus 94. They have to equal each other. Now, how would you solve for what each angle is? Well, isolate your x. Move this x over by subtracting 8x. This cancels out to get 9x minus 8x is 1x. Move this 3 over here by subtracting it. minus 3 to get x equals 91 degrees. That's not your answer, though. Well, obviously, I don't think this is going to be drawn to scale whatsoever. But anyways, this would be 91 degrees. To figure out what this angle is 91 times 9 plus 3. This would be 8 times 91 plus 94. These two are definitely not drawn to, I think what messes it up is this 94. If this was a 9, that'd be a lot more understanding, sure. But for the sake of this example, leave it 94. Sometimes you have examples where things are clearly not drawn to scale, which is totally fine as well. Okay, that kind of sums up everything that we did for the first unit of work.